Hello. In this video, I will demonstrate time series forecasting using multiple regression and also accounting for seasonality. So let's get started. Again, we want to conduct time series forecasting using multiple regression, identifying seasonal effects. The following data represents quarterly sales in thousands of a product over a 3-year period, and we wish to forecast sales for the first quarter of the 4th year, accounting for seasonality. We also wish to know if our data actually does include seasonal effects. So the demand in the first quarter of the first year is 10,000. The second quarter of the first year is 8,000. Third quarter of the first year is 12,000, and so on. We are now ready to construct our model. To solve this problem, we will use Excel regression command. But first, we must define our dependent and independent variables. The first independent variable will be time, and we construct it as follows. For year 1, quarter 1, t equals to 1. Naturally, this is our first time period. For year 1, quarter 2, t equals to 2. For year 2, quarter 1, t equals to 5. For year 2, quarter 2, t equals to 6. And finally, for year 3, quarter 4, t equals 12. Now we are ready to define what are called dummy variables to account for quarter effect, and these are binary variables defined as follows. We let qt1 equal to 1 if the time period t is the first quarter, 0 otherwise. We let q2 equal to 1 if time period is the second quarter, 0 otherwise. We let q3 equal to 1 if the time period is third quarter and 0 otherwise. We really don't need a fourth quarter binary variable, because if the time period is in the fourth quarter, qt1, qt2, qt3, they all will be 0, and that will account for the fourth quarter effect. So now let's construct the model. This is my raw data that I've copied from the other worksheet, and I'm going to use it to construct the regression model. To form the data input for the regression model, I need to put the dependent variable or the demand in the first column, so we'll call this demand, and the independent variables to the right of that. The first one will be time, next one will be qt1, next one will be qt2, last one will be qt3. Now I'm ready to enter the values. The demand for the first period of the first year is 10, the second one is 8, the third one is 12, and the fourth one is 14. We go to the first quarter of the second year, demand is 12, followed by 10, 13, and 15, and the next year, the third year, the first quarter is 13, 11, 14, and 16. And the time periods for these 12 demands are 1, 2, and I can just extend the formula as such for faster processing. There's my 12. Now I'm ready to define my seasonal effect or the binary variables. qt1 represents the first quarter, and this is the first quarter, so that gets a 1, and qt2 and 3 get a 0. We go to the second quarter, the first year, qt1 is 0, QT2 is 1, QT3 is 0. Next one is the third quarter, QT1 and 2 get a 0, 3 gets a 1. Go to the fourth one, 0 for QT1, 0 for QT2, 0 for QT3, and so on. I'm going to pause, complete the table, and then come back. Now that I have all of my data, I can go ahead and apply the regression command. I will click on Data, select Data Analysis, select Regression, click OK. I'm ready to input my parameters into the regression model. Notice that my columns have labels, so I will highlight label here or check mark it. Go ahead and input the Y range, which is my dependent variable, starting with the label all the way down. And then go ahead and input the X range. These are the values of my independent variables as such. And of course, regression command offers a bunch of other options that you can select if you're interested, and I'm going to allow it to put the results for the report on a separate worksheet, so I'll go ahead and click OK. Here we can see that regression generated the report and put it on a separate sheet. I'm going to go ahead and zoom the report and go through these parameters one at a time. Let me enlarge the label command here. To begin with, I'd like to look at the significance. The significance of F, which is the F-test, identifies whether our regression model is statistically significant. This is your regular p-value, and you can see that it's 1.5 times 10 to the minus 6, which is extremely small, indicating that our regression model is indeed statistically significant. R squared at 0.98 identifies the percentage of the variability in the dependent variable or the demand that can be explained by the independent variables, and it stands at 0.98 or 98%. And now this is the ANOVA report, and these are our coefficients. The coefficient, the intercept is 12.5. The coefficient of time is 0.31. For QT1 is minus 2.3. For QT2 is minus 4.7. And for QT3 is minus 1.68. So I can actually type in my equation for the forecasting model as follows. The forecast for time period T will be equal to, going to put the formula in this column. Now, you have to remember we're going to need a value for QT1, QT2, QT3, and same thing with time period. So I'm going to have time here, QT1 here, QT2 here, QT3 here. And to get things started, I'll just hypothetically put, well, actually we wanted to forecast for the first quarter of the fourth year, so that would be time 13, and QT1 would be 1, QT2 would be 0, QT3 will be 0. I can now build my forecasting formula. My formula is going to be equal to, first thing is the value of the intercept, plus 0.3125, the multiplier times time. In this case, plus, but that's a minus value, but I'll go ahead and put a plus because the the sign will be incorporated automatically. So the multiplier for QT1 multiplied to the value of QT1 plus the coefficient for QT2 multiplied to the value for QT2 plus the coefficient for QT3 multiplied to the value for QT3, and that will give me the forecast for the first quarter of the fourth year. One thing we may want to pay attention to is, are these three seasonal effects actually significant statistically? So we can take a look at the regression report and we will focus on the p-values. These p-values indicate the significance of each of the variables, including the constant, and we can see that they are all extremely small, definitely less than 0.05 or 0.001, indicating that each one of these, the intercept, the time, QT1, QT2, QT3, are statistically significant. Now let's assume that I actually want to forecast for all 4 quarters of the fourth year. So let me demonstrate that. The first thing we do is we are going to copy the regression function coefficients to the other worksheet so that we can create our formula. I'm going to just copy from here to here and then go back to the model and then paste them here, let's say. So I've got my regression function coefficients. Now I'm going to enter the time value. Obviously we want to go to the next year, so I am going to highlight those and then pull down until 16. That's my fourth year, and then I'm going to enter values for the seasonal effect dummy variables. This 13th period is the first quarter, so it's a 1 and a 0 and a 0. Second quarter, this one is a 0, this one is a 1 and a 0. This is the third quarter, so there's a 0 and a 0 and a 1 here. And then obviously the fourth quarter, the dummy variables are all 0. Now I can build my forecasting equation. This is going to be equal to, as before, the intercept, and we will make sure that the cell reference for this is absolute, so that when I copy the formula it won't change, plus the time variable multiplied to the coefficient for time, make it absolute cell reference, plus the first quarterly effect variable multiplied to the coefficient, the regression function coefficient for that, making sure it's absolute cell reference, plus the next one multiplied to the next coefficient, finally plus the third dummy variable multiplied to its coefficient. And as before, this is the forecast, estimated forecast is 14.2. Now I can just copy this all the way down to here, and I get forecast for the four quarters of the fourth year. Let me also show how one can calculate the error term. And I'm going to just calculate the mean absolute error. So this column will be error, and this is going to be the absolute value of error, because I want to calculate the mean absolute error, and the error value is going to be equal to actual demand minus the forecast. And I can just copy this all the way down. Notice that I don't have actual observed value for the fourth year, so I can only do it for the first 3 years. And then this is going to be equal to the absolute value function for the error value or the error term, and I'm going to just copy that all the way down here, and my mean absolute error is going to be equal to the average of these error terms. The mean absolute error value allows us to compare different forecasting models for a given set of time series data. And that is how we use multiple regression using dummy variables to account for time series forecasting that has seasonality effect in it and accounting for the seasonal variations.